Example 6 and 2.2 from Math 20-1 is very similar to example 5, except it has a little twist where it wants us to round to the nearest tenth of a degree. Students typically like these questions because it means we get to use our calculator much more than we would have to using our special triangles. And it's certainly useful, but we want to push that special triangles algebra because that's what you're going to need in Math 30. But we're going to do the same technique. We just don't have to do the special triangles for this question, which is why I said typically students like it. So it is telling us that cos theta is equal to negative 0.76753. So according to CAST, cos can't be cos can't be positive because it's negative. So it's not in quadrant 4 or quadrant 1. Now, same as we did in example 5, if cos theta is equal to negative 0.6753, then the cos of theta reference is equal to the absolute value of what that number is. Now, we've done a lot of absolute values, so I'm going to jump right to the next line, which is the cos of the reference angle is just positive 0.6753. And now we get to grab our calculators because in order to solve for our reference angle, we have to take the inverse cos on both sides. And I'm going to write that out one more time, that I am applying the inverse cos onto the left-hand side and the inverse cos onto the right-hand side. The reason I want to do this is on the left-hand side, the inverse cos and cos cancel. And I get that theta reference is equal to the inverse cos of 0.6753. You need your calculator for this. Any scientific calculator will have the trig functions. On the TI calculators, the way that we get to those trig functions, at least the inverse, is you hit second cos, and you'll see the little -1 in place there, and then 0.6753. The calculator tells me that that's at 47.5225. So 47.5225, and that number does carry on forever. The question does say, round your answer, up here to the nearest tenth of a degree. We are going to round at the end, all right? Just like in physics or most science classes, we typically round our final answer only. What we do know now, though, is that in quadrant 2, if I draw my angle here, then this is my 47.5, blah, 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 degrees. In quadrant 3, when I draw my angle, this is my 47.5, that reference angle right there. And again, 3 dots there as well. Certainly, again, the algebra or not, depends on what you like to do. My answer in quadrant 2 looks like that. And theta reference is equal to 180 degrees minus my rotational. I'll show the manipulation here. We could say that theta r plus theta is 180. So the rotational angle itself is 180 minus the reference angle. So we can say that that theta is 180 degrees minus 47.52, blah, blah, blah. One nice thing for students to remember is that if you lose that number on your calculator, you can always get to it by the inverse cos of 0.6753. And so if I was going to try to find that angle in quadrant 2, I could actually type that into my calculator. So 180 degrees minus the inverse cos of 0.6753, and I get that 132.477. So try to keep in mind where the numbers came from, because that can be a really big advantage when you're trying to give the actual numbers themselves. So in quadrant 2, I got 132 I forgot already. Good thing I can access it. 132.477. Oops, 132.477. And that's in degrees. Because we're rounding to the nearest tenth, we would say 132.5 degrees. So that's one of my answers. The other answer is this theta right there. And we can find that by using our reference angle formula. In this case, it is the angle in standard position minus 180. So that means that theta is equal to theta r plus 180 degrees. I'm going to write out what I'm doing again on my calculator. I am, because I don't want to write that number more than once, just going to take the inverse cos of 0.6753 and add 180. And what I end up getting is the inverse cos of 0.6753 should still be that 47.5225. When I add 180 to that, I get 227.5225. And then to the nearest tenth is 227.5 degrees. Now, if you wanted to check this on your calculator, you could just type in, I'll just box that so we know it's an answer. If I wanted to check it, I would just type into my calculator, cos of 227.5. When I put that into my calculator, what I get is negative 0.67559020076. That is not exactly the same thing as we started with, right? The number we had above was negative 0.6753. It's not exactly the same, but that's because we rounded it. Because we rounded to the nearest tenth, we should expect it to be accurate to at least the nearest tenth, and it is. If we use this unrounded number, it would have given us exactly negative 0.6753. So as soon as you start to round in these questions, you have to understand that, your verification has to take that rounding into account. All right, so I'm going to put up the full assignment if I can find it here. Keep in mind on Google Classroom, we are going to have that modified assignment for you to do. Chapter 2 is tricky, but it's very important. 3 chapters in Math 30 contain this type of trigonometry. Please keep working at it, and it will click. It just takes a little bit of time and a lot of practice.